Okay, so for this problem, you have a graph that looks like this, and then we're supposed to, on the grid below, graph the velocity of the elevator as a function of time. So this is x versus t. This is v versus t. And so then this slope right there, that's going to be the first value. And I think that goes up to, what, 8 seconds? So from 0 to 8, it's whatever that slope is, m1. Okay, then obviously from here to here, which is like 10 to 18, from 10 to 18 seconds, so I don't know, from here to here, the value is 0. So you just color in on the line. And then from 20 to 26, from 20 to 26, this is M2, which is obviously some negative value down here. Do you see what's happening to the slope of this curve? Yeah, it's just decreasing down to 0. Okay, so then you can have something like this. You can have something like that.
Why did it stop at 9 seconds?
If you take a look at the stop at 9 seconds. Oh, you mean like if? Okay, I'd say like if you look really closely, maybe you would say it's at 9, but I would say start and stop like
At the point where
yeah, at the point that's clearly delineated. So if you look at 9 seconds, it's
it's like
maybe it's flat, you know, like 9.3 seconds or something like that, but you can just make it easy on yourself. They're trying to see if you understand that this is the slope of that. Okay, that's the point there. All right, then we look at part B, says calculate the average acceleration for the period of 8 to 10 seconds. So average acceleration is delta V over delta T. So we get V final minus V initial over delta T. And just do the calculations, right? 0 minus, what was M1, what was the slope?
I think it's 3. How much? 3.
The first slope was at 3.
I don't know.
I see a rise of 6 over a run of 4.
Oh, 4. I was just kidding.
So I get 1.5. Please take a look at that and see if you agree with me. Do you see it? Do you get a value of 1.5 for that? This part? Okay, so then that gives me 0 minus 1.5 over 2 seconds, which gives me an acceleration of negative 0.75 meters per second squared. Everybody cool with that? Sorry, this is B. Yeah, this is BI. Then BII says, on the box below that represents the elevator, draw a vector to represent the direction of this average acceleration. Well, I mean, I don't know, one word, duh. If this is negative, which way does it point? Yeah, down. Acceleration's down from 8 to 10 seconds. Right, that's one of those things where you probably thought yourself out of the right answer. It's like, oh, frame of reference, blah, blah, blah. It's a negative number. Okay, and if we say this is a positive and it's going up, does everybody see this elevator goes up, slows down, stops, then it comes back down? So just, keep it simple, students. Use the KISS method on that, okay? C, suppose that there's a passenger of mass 70 in the elevator. Calculate the apparent weight of the passenger at time t equals 4 seconds. So for C, at time t equals 4 seconds, 4 seconds, 4 seconds, 4 seconds. What is the acceleration at time 4 seconds? Wait for it. Can you believe I went over on my text for this month? So if you need to contact me, call me. Don't text me. Or you can IM me if you see that. Bevan, what is the acceleration here at 4 seconds? Okay, 1.5 meters per second. meters per second. What does that sound like, Brevin? Is that an acceleration or is that a velocity? Velocity. Take a look at this slope. What do you know the slope of the velocity versus time graph is in fact the what? The slope of the velocity versus time graph, Signy, is what? Acceleration. So what is the slope of this line here, Bev? This is exactly what I was saying before class. One of those things where you get asked a question and like the nervousness takes over. Remember, slope is rise over run. How much does that line rise? How much does a horizontal line rise? Oh, pick that again. Clayton, can you help him out? What is the slope of that line right there? Exactly. Okay? It's 0. The slope is 0. So part C says, calculate the apparent weight of the passenger. Well, the apparent weight of the passenger is just going to be, you would say the sum of the forces is equal to ma. And if a is 0, then that means Fn is going to equal Fg. So the apparent weight is mg. It's just mass times gravity. That's it. Ah, now we get to pick on someone else. Let's see. Have I stopped it? Oh, you were supposed